everybody. Today we're going to look at systems of conics, and so we'll kind of just go back and do a quick review on what a system is. So a system is basically just two or more equations, and when you were in Algebra 1 you learned how to solve them really three different ways. You learned two different ways that fell under the algebraic heading. You used something called substitution and elimination. Some of your teachers might have called the elimination method linear combinations. It doesn't matter the vocabulary you use, but basically you eliminated one variable and then used its value to find the other. And then you have graphically, which is a method where you would at the time graph both lines, but in the same space. So the goal of solving a system, which is really what we're going to be doing, is that the solutions to the system are the places where the graphs of the equations would intersect. So you again can find out that information algebraically during these two previous methods, or you can do so graphically. And it was possible then, and is still possible now, both in Algebra 1 and currently in Pre-Calc, for you to have no solution. And you would have no solution if the graphs never intersect. So I took an example from Algebra 1, and I basically solved it in all three ways, and I'm just going to quickly touch upon it and make sure that these skills are kind of refreshed for you. You did it as well in Advanced Algebra, so it should hopefully come back pretty quickly, and if not, just let me know if you need some additional examples. Under substitution, you pick an equation. You can choose the first or the second. I chose the first equation, and you solve it for a given variable. So I could solve this equation for x or y, but it's just technically easier to solve it for y. So when I solved it for y, I did so without showing a lot of work. If you need to take a moment and pause the video and kind of see how I solved that for y, you can, but basically I added y to this side and subtracted 8 to get the y by itself. Then what you're going to do is substitute, hence the name of substitution. You're going to take this entire expression of 2x minus 8 and you're going to put it where the y used to be. So you're basically doing a replacement, hence the word substitution. So where you have a y in the second equation, you replace that y with what y equals. Okay, so you do a direct replacement. The rest of the equation is getting copied down. You then will basically combine like terms and solve the simplified equation that now, instead of having two different variables, only has one variable. What you'll do then is take the x value that you found. It doesn't have to be x that you find first, but in our case we did, and you'll use that variable to find the other. So you'll go back to one of your two original equations, and you will make that replacement. I personally am usually going to go back to the original. Now here you see I use the solved version, which is fine. It's probably safer to use the other option. But either way, you put the -1 in, you simplify to figure out what the y value is, and then you combine them together. Obviously the x would come before the y because we're representing an ordered pair. Now under elimination, what you did is you stacked the equations vertically and lined up their x's and y's and constants on the other side, and you looked for a way in order to eliminate a variable. So what you wanted was the same coefficient. In our case we have a -1 and a +1. We wanted the same numerical value but opposite signs. Once we were to create that or have that situation, we could add vertically. The y's would drop out. 2 plus a -3 is -1. Adding vertically -7, you get 1. You then finish the solving. You can see right now that since it's the same solution or same system, we have already the same value for x as you would expect, but just a different method of obtaining it. So we'll still use our x to find y, putting it into an original equation, solving through to get our y value. And again, putting the x and y together as an ordered pair. If you forget this step, it will be a point deduction. Lastly, you have a graphical method. In order to graph these equations, these are in standard form. In your algebra experience, you have done a lot of graphing from standard form for lines, so it usually is best to turn it into slope-intercept form. So if you solve for y, it puts it in slope-intercept form. You can do the same thing with the second equation, graph both of these, and if graphed carefully and accurately and using a straight edge, you will see once again that the place that they intersect is at -1, -10. So no matter the method you choose or are asked to perform, you will get the same answer.